on the YouTube page. And if I either upload them tonight or tomorrow morning, just give me that courtesy. This is now recording just so you guys know. So let me tell you how tonight will run. Homework number 2, which I think pretty much everyone did, and they looked really good. I want to just also say when I grade your homework, I'm eyeing it over to see that you have the idea, and I'm grading it out of your completion. You should be making corrections. So when we go over the homework now, you should be making corrections. And I also do post the answer key either tonight or tomorrow morning. So we're going to start with homework number 2 as soon as I'm done with this whole rant. I promise it won't be long. We're going to complete lessons 3 and 4. Lessons 3 and 4 will be what are on your exam. Now, I'm going to talk about the exam at the end of class because more people will probably be here. And then you don't have to hear it twice. But I did take the exam that was scheduled for this Wednesday, and I've moved it to after our spring break, which is next week. I'll talk about how the exam is structured, how you can take the exam and all of that, but we're going to do that at the very end. So I'll ask you if you can please stay on here. Don't leave too early on me because I don't want anyone to miss anything. So I'm going to say we're going to run class the same way. Again, I really thank you guys for being so understanding and great. You're an amazing class. Even when I see the homework submitted, I have like 1 to maybe no homeworks missing. So thank you from the bottom of my heart. You're an amazing class so far, and I know it's only going to get better from here. So we're going to go over the homework right now. I think I'd like to throw a couple of extra problems at you. So I think we'll try a few of those. And then we're going to go into finishing lessons 3 and 4. I'm going to ask you guys, like usual, to please wait until I open for questions. Some of you guys, and you're so respectful, and I love that. But once I ask for questions, you guys can just ask the question. You don't have to ask any permission. You don't have to ask anything like that. Just shoot with the question. So let's get started with tonight's homework, and then we'll go from there. So for number 69, and by the way, they are numbered this way because I did steal them from the textbook. We are going to, oh, you know what? Before I have the issue, I'm going to switch to my other router. So I may be a little bit paused. Give it a sec. Okay, I should be on the router now. So you guys should be able to hear me. Can you guys hear me? Can someone give me a yes, a thumbs up? Okay, thank you. I got a thumbs up. I remembered to switch to the router. So I'm going to go over these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 problems. Then I'm going to pause for questions. So I'll ask you to wait until I open up for questions, and then you're welcome to ask, just so we can keep a flow. So remember, when we multiply, we're going to multiply coefficients. When we multiply bases that are the same, we're going to add the exponents, and we're going to add the exponents. So you should all have gotten 2x to the 12th, y to the 13th power for our first example. And again, I'll just say, put a little note to yourself if you need me to go over or explain something further afterwards. For 70, you're going to have 9 times 2, which is 18. S to the 3 and S to the 2 is S to the 5. T to the 6 and T to the 1 is T to the 7th power. Also, please remember that you should never have negative exponents. We will talk about that later. For the next one, 4 times 5 is 20. A to the 2 and A to the 10 is A to the 12. B to the 2 and B to the 9 is B to the 11th. Again, no negative exponents. Our rule for 75 and 76 will also be similar. So we're going to divide our coefficients, and then we're going to subtract from top to bottom. Again, if it makes you feel better, you can always put an imaginary 1 as your placeholder for your exponent. Now with 76, the negative happens to be in the bottom, whatever. It could go in the top, it can go on the side. As long as you understand that the exponent is negative, you're in good shape. Excuse me, that the fraction is negative, you're in good shape. So we know this is going to be negative. 18 and 54 do not reduce to a whole number, but they do reduce to a fraction, 1 over 3. And again, that is knowledge from before. X to the 7 over X to the 3 is X to the 4. Y to the 8 over Y to the 5 is Y to the 3. So you can write it like that. You may see your answer written as 1/3 X to the 4th, Y to the 3. They mean the exact same thing. As long as you're showing that it is either 1/3 times those variables, or that the X to the 4 and the Y to the 3 is on the top, then like I said, you're in good shape. Please recall that.
Sorry, Professor.
Okay, so I'm going to ask again for you to hold on any questions. If I keep having to pause, it becomes very tough. So I'm just going to ask for you guys to please wait, and then I will give you an opportunity to ask questions. I really need to keep this flowing and fair. For 78, we're going to have 3x to the 0, which is going to be 1. The reason being that the entire parentheses is being raised to the 0. Versus in 79, only X is being raised to the 0. So this is the same as 3 times 1, which is 3. So again, noting the strength of parentheses, the fact that everything is in the parentheses means that it becomes 1, versus only X to the 0 being raised to the 0 means it's 3 times 1. For 81, we are going to have this -12, t to the 4th will be on the outside. Order of operations. So again, we've discussed PEMDAS. Parentheses always come before anything else. You should know that there is multiplication here. So this entire 10 s to the 8 t to the 0 is raised to the 0, and that means this whole thing becomes 1. And so the final answer is just -12 t to the 4th times 1, which is -12 t to the 4th. By the way, it's always a good idea to box in your final answers. It helps when you're taking an exam, but also to just keep track of your work. Finally, the last two, and then anyone with any questions can open up. So again, this entire thing was in parentheses, which means the whole thing becomes 1. And finally, we have 2 sets of parentheses raised to the 3rd power. So we're going to deal with them separately. So I'll start with the one on the left. Remember that when we raise a power to a power, we are going to multiply the 2 powers. So we're going to have m to the 6th power, and then n to the 21st power. Again, that's the first set of parentheses on the left side. For the right side, and again, there is multiplication here, we have to also remember to raise all of our coefficients to the power. So a negative raised to an odd power is negative. -6 times -6 is 36. 36 times another -6 is -216. M to the 1st is being raised to the 3rd, so that's m to the 3rd. And n to the 8th is being raised to the 3rd, so that's n to the 24th. So again, we start with parentheses, then by order of operations, we go to exponent. From there, we are going to now multiply these two things. So -216, remember that when we multiply bases that are the same, we add the exponents, and the final answer is -216, m to the 9, n to the 45. So I'm going to ask you to raise your hands if you have questions so I can keep it fair and organized. We're going to then go over the bottom piece after. Maria, thank you for waiting. Go ahead.
Yeah, sorry for interruption. Number 75, I got 6s to the 4th, t to the 4th.
That is of 35 divided by 5, which is 7.
Oh, yeah. Sorry about that.
No problem.
Yeah.
Indira?
Can you explain 76 again?
Absolutely, I can. So 76, if it was 54, forget the negative for a minute, okay? If it was 54 over 18, it would be 3. But because it's 18 over 54, it's 1 over 3. Is that the part that's confusing?
Yes. So I divide.
You're always going to reduce, so I would suggest if this is a little bit of an issue, you're gonna go over reducing fractions. You would divide by the value that is common to the top and the bottom. Again, I'm also gonna say that that is knowledge for this class that you
Yeah.
have, so just review it if anything.
Mhm.
But it's 18 and 54 have 18 in common.
And then, and then the
Back the
7 and the 3 is,
4 and y to the 8 and y to the 5 is 3.
okay, I get
Okay.
it now.
And by the way, if anyone, if you feel that your question is a little rushed sometimes and you guys, I answer it and you're still confused, this goes for everyone. I'll say then just stay on at the end and let me know and I'll go back to it. I just have to maintain the time, guys. It's not that I'm trying to rush you. So stay on and I can always go over. David, and then I'm going to move to the bottom. Just unmute for me, David.
I'm sorry.
That's okay.
I just wanted to adjust the notes, my notes, because as you can see, as I submitted my answers.
Okay, so
the-
if it's a personal thing, David, I'm going to ask you to wait till after class. Okay, but I will say for everyone, because this is important, for everyone, work has to be shown. So stay on for me after and you and I can discuss. I really want to move through the math, okay, unless it's a math-based question. Okay, so numbers 51, 52, 53, and 54 all have the negative exponent. This was the last property that I taught you guys last week on Monday. So what I'm going to do is I'm going to re-explain how these work. If you have a negative exponent on the outside of the parentheses, you're going to take the reciprocal or flip the fraction to make it positive. So the b to the 6 goes on top, the a to the negative 3 goes on the bottom, and now you can see the exponent becomes positive. Remember, you are raising b to the 6 to the 2, which is b to the 12th. You're raising a to the negative 3 to the 2, which is a to the negative 6. Now the directions will always say positive exponents only. So if you have a negative on the top, you put it in the bottom. Let me make the little notes here. So a negative on top, put in bottom. I'll put place in bottom. It sounds a little better. And then a negative on the bottom, you're going to put or place on top. So the b to the 12th is fine. The a to the 6th or the a to the negative 6th is not. So I'm going to rewrite this as a to the 6th, b to the 12th. I also remember last week that not a lot of you, some of you guys asked me about the fact that why did I put the a before the b? Because in math, it is always appropriate to put your variables in alphabetical order. If you write your answer as b to the 12th, a to the 6th, it's not wrong. You won't be marked wrong. But if it's a multiple choice exam, you will only see that as your answer. So just keep that in mind so that you don't get confused. Let me do the next 3 and then I'll pause and then we'll finish up with the last 2. So again, my exponent is negative. So I'm going to do a little flip. N to the negative 8 on top, m to the 4 on the bottom. My exponent now is positive. So I'm going to have n to the negative 24th on the top and m to the 12th on the bottom. Now this time the top has a negative, so I'm going to flip it down into the bottom. And you have to understand that I'm not going to leave nothing on top. So what I will do is, because the n is going on the bottom, a 1 goes in place to show that there was something once there. So the final answer there is 1 over m to the 12th and to the positive 24. For number 53, again, I'm going to do a quick flip. So b to the negative 7 on top, a to the 0 on the bottom, and now my exponent is positive. So I'm going to have, sorry about that, b to the negative 14. And of course, anything times 0 is just going to be 0. And what's nice about this is anything to the 0 power is 1. Again, the b being to the negative 14th breaks the positive exponent only rule. So I'm going to flip that in the bottom. And because there is nothing left on the bottom, a 1 will go as a placeholder. So 52 and 53 are very similar in that nature. Finally, for this last one, b to the 0 on top, a to the 3 on the bottom, and now we're raised to the positive 10. So again, I'm going to get, sorry about that, b to the 0 on top and a to the 30 on the bottom. Again, anything raised to the 0 is just 1. And the fact that 30 is already positive means we are in good shape. Okay, so at this point, if there are any questions on those 4, I'm happy to answer. And if not, we're going to just go to our last 4 or our last 2. And then if I have a little time at the end of class, maybe I'll make up a couple of more. I really want to make sure we cover all of our material this evening. Okay, so again, based on order of operations. Go ahead, Marian.
I'm sorry, I have a question.
Oh, guys, you never have to apologize about questions. Just when I open up, you can do it. Go ahead.
So my question is can you scroll up a little?
Absolutely.
With 52, how
Okay.
did you get 1 over, like I got the bottom part of M12 and over 24, but how did you get 1 at the top?
Because if you, I'm going to just do it down here because I don't have enough space. So if we're going to flip this into the bottom, we have to show that this is now becoming a fraction. And so we can't just leave it like this because this doesn't really make sense. So what we're saying is there was originally like a 1 times this on the top. And so only the 1 stays up there. So basically, if you flip stuff into the bottom and there's nothing left on top, a 1 goes there as a placeholder. Same deal like number 53.
Okay.
Okay. As a matter of fact, I'll try to do another one at the end of class. I'll make a little note in my notes here to try to do that at the end. All right, 69 is our next one. So again, we have to follow our order of operations. So exponent, well, parentheses, then exponent. So we're going to start with, let me zoom in a little for you guys. 3 to the 2, which is 9. X to the 1 raised to the 2 is 2. Y to the 3 raised to the 2, y to the 6. Now remember, guys, there is multiplication there. So I think it's very important to put that times from the beginning. So we get 54, x to the 6. Remember, we are adding the exponents, and y to the first power, which is just y. And because we do not have any negative exponents, that's our answer. Same deal with 70. So 4 to the 2 is 16. X to the 2 is x to the 2. Y to the 2, because it's y to the 1 raised to the 2. Again, there is that multiplication. So the coefficients, -3 and 16, is -48. X to the 5 and y to the -5 when I add my exponents. Now, let's just imagine you guys are taking an exam and you get here and you go, all right, let me look for my answer. And you don't see an answer like this. Well, why wouldn't you see an answer like this? Because that negative exponent breaks that rule. So the negative exponent of y would flip into the bottom, and now we are positive. Okay, so I will, of course, upload this work for you guys. If anyone has any last minute questions, I will take them now, or if you want to wait till the end, you can do that as well. It's up to you. I want to pick up where we left off with our notes. So the agenda, in case you missed it, we've now reviewed homework number 2. We're going to complete lessons 3 and 4. And then I'll talk about the exam, which I did move to 4-5. So please don't hang up too early so I don't lose you guys. All right, so lesson number 3, which I started with you guys and I was supposed to finish Wednesday and I didn't. Let me just quickly recap what we did so everyone is clear. By the way, I'm going to be honest with you guys. I'm not asking any questions where you have to pick out the leading coefficient on your exam. I'm not asking you what the degree is. That was just a conversation for us. We did discuss standard form of a polynomial. So standard form of a polynomial is going to be where we have the exponents in decreasing order. Okay, so we're going to start from the top and then decrease till we go to the constant, which doesn't have a variable. And then, of course, we discussed adding and subtracting. So when we add, we can simply add the coefficients and we add terms that are the same, so they have the same variable parts. We also discussed the importance of when we are dealing with subtraction, that we can distribute the negative into each term of our second polynomial. We're going to add on to that right now, guys, by talking about multiplication. So I know I picked up with this on as the end on Monday, but now we'll just quickly review. So I already told you guys that you'll already know how to do the left side. That is all just multiplying two monomial terms. We just spent the last 20 minutes doing so. For the second one, when you see a single term, okay, times any polynomial, we use the distributive property. So I'm actually going to do one more of those just to show you. And then we're going to move to a binomial times a binomial. So let's do 5x cubed times 2x squared minus 3x plus 4. I'm going to give you guys a minute to see if you remember what to do. So I'm actually going to hide the work. Let's see if you guys try not to look at anything on the bottom, and let's see what you guys can do. So I'll give you guys about less than a minute, 45 seconds to do so, and then we'll see what you guys got. Again, if you came in a little later, I thank you for last week. I assure you that should not happen again. So please keep in mind that we will be good, smooth sailing till the end of the semester. Okay, so a few more moments to try this out. I have little notes if you see me looking around. I got 400 devices going at once here. All right, so let's see. 5 times 2 is 10, x to the 3 and x to the 2 is x to the 5. 5 times negative 3 is negative 15. X to the 3 and x to the 1 is x to the 4. And 5 times 4 is 20. And then we simply attach the x to the third. So that is what we call our distributive property. And we're going to take our distributive property and we are now going to go and sort of extend this into our next piece, which is where I left off with you guys last time. Many of you, especially if you did this in high school, or maybe you have high school age children or cousins, you may remember FOIL. So this is one way to think about this, but I'm going to also introduce another way as well. So F stands for first, O stands for outer, I stands for inner, and L stands for last. And I will demonstrate how FOIL works. I'm going to actually move it over a little bit. I'm going to demonstrate how FOIL works in each of these examples. So I'm going to model these 4 examples for you. And then underneath, you guys will have an opportunity to try some without me. So please let me just model these. And of course, after I model them, I'll take any clarifying questions. So what FOIL basically is a fancy pants way of the distributive property. We're going to take each term of the first binomial. Binomial means 2 terms. And we are going to distribute into each term of the other binomial. So let me explain. X times x is x squared. That's your F, or your first. X times 2 is 2x. That's your outer. Now I'm going to come underneath with my arrows. So 1 times x, which is my inside or inner terms, is 1x. And 1 times 2 is my last terms, and that is 2. If you don't like FOIL, you're just going to take the first term and give it out to each, the second term and give it out to each, and then my arrows show the direction. The middle terms are the only like terms, so the final answer will be x squared plus 3x plus 2. Now, most of the time, the middle terms will be like, but sometimes they won't be. So just keep that in mind. So I'm going to keep going. Let me do the other three and then I'll open up. So x times x is x squared. And this might be coming back for some of you. X times 9 is 9x. Coming underneath, negative 2x and negative 18. X squared plus 7x minus 18. Again, my middle terms are my like terms. I'm just going a little slower here to let you guys sort of digest this and play a little catch up. Okay, so the next, I have a little bit of more coefficients involved. So 3 and 2 is 6, and then y and y is y squared. 3y times negative 1 is negative 3y. Coming underneath, negative 10y. There are my like terms. And then plus 5. So it's the same ritual every time. It is not like I have to reinvent the wheel. I also believe that some of you guys may, or you should have seen this in M200 if you took that. So this really isn't too much of a new experience, but if it is, that's okay. But you guys will get good at it. So the last two, again, I made this one a little more tough. You probably wouldn't see this on an exam, but I like to challenge you guys. So negative 4 times 4 is negative 16. X times y can only combine to an xy. You can combine two variables that are different when you multiply, of course, not when you add. Negative 4 times negative 8 is positive 32. So you have an x times an x, which is an x squared, and then a y attaches. 7 times 4 is going to be 28, x and then y squared. And then 7 and negative 8, I'm going to have to squeeze this in here, is negative 56. There are two x's and there are two y's. Unfortunately, we do not have any like terms, so there's no combining that we can do. Okay, so does anyone want me to explain anything further here? If not, I'm going to go through more examples before you guys try. Okay, I'm just going to give people a minute to digest this. And then I'm going to talk about special binomial products. It's not that anything changes. You're just going to see that certain terms will cancel because they combine and go away. But the whole idea is the same. So I really like the arrows because the arrows kind of make you or force you to really pay attention to what you're multiplying. I'm also going to put a star around D. I would never ask you a question like D, and you most likely would never see a question like D on an exam. So these are called special factors. These are something that we will explore later. When we do our factoring, you will see something called a difference of squares. Which means that we are multiplying two binomials that are the same. Let me zoom in so you guys can see better. One is plus in the middle and one is minus in the middle. And you don't have to memorize this because I'm just showing you how the structure will work. So don't freak out and think, oh my goodness, I have to memorize. If you multiply a plus b squared, it's that binomial times itself. And again, you don't have to worry about that last line there. And if you multiply a minus b squared, it's a minus b times a minus b. I'm going to point these out as we go, and I'll write down which Roman numeral these apply to. So a is Roman numeral 1, a difference of squares. X times x is x squared. X times negative 3 is negative 3x. I'm still using the same procedure, guys. Plus 3x minus 9. The two middle terms cancel because negative 3x plus 3x is just 0, which means I get x squared minus 9. Letter B is another difference of squares. Y times y is y squared. Y times 6 is 6y. I can't do the arrows because then I'm going to smash this all together. Negative 6y and negative 36 my middle terms cancel. Number C, or letter C, is also a difference of squares. 2y and 2y is 4y squared minus 18y, inner terms plus 18y minus 81, and again, the middle terms cancel. Finally, D is also the same type, so I'm just going to kind of separate these from the others. Actually, that line's going to now, well, I'll do it over here. So 3a and 3a is 9a squared. 3a and 10 is 30a. The middle terms minus 30a, and then minus 100. Middle terms cancel, and there is your solution. Letter E, F, and G are the second and third Roman numeral, where you are taking a binomial and you are squaring it. So x plus 4 times x plus 4, excuse me, x plus 4 squared is x plus 4 times x plus 4, which will eventually give you this. 5 minus 11x squared is 5 minus 11x times 5 minus 11x, which will give you this. And then the last one is 3a minus 10b squared. There's a squared missing there, guys. I apologize. Please throw that squared in there. I must have not typed it in. So it's 3a minus 10b times 3a minus 10b, which eventually gives you that. Okay, so if anyone wants me to explain any of these further, I will do that. I'm going to actually ask if you are ready to start these 4 examples, 5 examples right here. I might throw one more if we have time. Maybe I will. Let's throw an F in there for the sake of, oh, you know what? We don't need one. You guys are good. Let's do one. So let's do 7y minus 1 squared. So there are 6 examples. I'm going to put a timer. I'm going to give you guys about, I really don't want to give more than 3 to 4 minutes. So I'll say by 8:45. Okay, so if anyone wants to ask any questions at this point, feel free. If not, I'll give you guys time constraints. We're doing really well on timing tonight, guys. And of course, please note this is being recorded, so I will post this for you. Okay, you guys have about 2 minutes left, 2 to 3. Okay, let's say 2 minutes remain. You should be up to at least C to D by now. Okay, about a minute to a minute and a half. If I finish lesson 4 a little early after I talk about the exam, I may just start doing a little of the homework with you guys to alleviate the amount. We'll see. Obviously, more practice is better, but let's see how things go. So 30 more seconds, guys. It's just around 8:44. I'd like to start by 8:45. Again, I really try to be cognizant of your time. Okay, so let me begin with A. You guys can follow along. So we should have x squared minus 8x. So you should be checking now, plus 2x minus 16. Final answer is x squared minus 6x. Sorry, that should be a 6 minus 16. Letter B, 4a times 4a is 16a to the 2. It's a little hard to do the arrows. 4a times negative 5 is negative 20a, minus 12a in the middle, and then plus 15. You guys should have 16a squared minus 32a plus 15. Okay, so hopefully you're 2 for 2. Letter C, so 11 times 3 is 33. Sorry about that. 11 times negative x is negative 11x. Now I'm going underneath. So negative 2 times 3 is negative 6x. And negative 2x times negative x is positive 2x squared. 33 minus 17x plus 2x squared. And if you want to write this in standard form, the exponents would go from top to bottom. So it doesn't matter, but I'm just going to let you know. So I'm going to write an SF there for standard form. So I'll pause just so you guys can catch up. Then we'll do the last 3, take questions, and then we're going to finish up lesson number 3. And it seems like you guys are okay, so that's great. Okay, so D is the difference of squares. Sorry, my Venmo stuff's popping up. D is the difference of squares. So you guys are going to have 2 times 2 is 4y squared plus 14y minus 14y minus 49. The middle terms combine to cancel, and we are left with 4y squared minus 49. By the way, again, I just want to reiterate, and we'll get more into this later on in the semester, a difference of squares is the same binomials, just one is plus in the middle and one is minus. But again, you don't have to worry about that just yet. Number E or letter E is the binomial squared, so it's the binomial times itself. This is always a really good final exam question. 4a squared from 2a and 2a plus 24a plus another 24a plus 144. 12 times 12 is 144. 4a squared plus 48a plus 144. Last but not least, 7y minus 1 times itself because of the squared. So we're going to have 49y squared minus 7y minus another 7y plus 1, 49y squared minus 14y plus 1. Okay, so any questions on FOIL or binomial times binomial from anyone? We're going to practice it one more step in a moment. Okay, so the last type, which I'm just going to demonstrate one of these, and then you guys can try the other 3 without me, is a binomial times this is a binomial times a trinomial. I always see this on the final, always. Okay, I'm going to tell you right now, it's on my exam. Okay, so let me explain how it works. Because I don't have a lot of room, I'm going to write them down here. So we're going to have x plus 3 times x squared plus 2x minus 3. Guys, nothing changes about the process. Instead of giving the first term out twice, you're giving it out 3 times. But I'm also going to show you something that might help you when you're setting up your work. So if you want to just watch and then right after, or you can do it with me. X times x squared is going to be x to the third power. X times 2x is going to be 2x squared. And now I'm giving it out a third time, so x times 3, negative 3, I should say, is negative 3x. So I've given the x out to all of the terms of the trinomial. Now I'm going to come underneath, and I'm going to demonstrate this by showing you guys in a different color. So let me just really emphasize this now. So now 3 times x is 3x squared, but instead of putting the 3x squared over here, I'm going to do something better. People always tell me this is really helpful. I'm going to line the 3x squared up with its like term, which is 2x squared. That way, when I combine my terms, I don't have to think very much. 3 times 2x is going to be 6x. So I'm going to line that up with the other like term, which is the 3x or the negative 3x, and then minus 9. So when I add these together, I get x cubed, because there's no other cubed, plus 5x squared. Look how easy this is. Plus 3x minus 9. Okay? Because I wrote all over D, I'm going to write D over here if anyone needs to see it. But if not, I'm going to give you guys these next 3 to do. As a hint for numbers C and D, with C and D, I would multiply 2 of them together and then use another. So C and D may prove to be a little tricky, but you know what I'm going to say? Who cares? You guys can handle it. So try those out. Then we're going to go into lesson 4, and hopefully we'll finish that in good timing. So that way we're caught up with all we need. It is 8:51. These are going to take you guys a little bit more time. So I'm going to put about 5 minutes on the clock, but I may start a little before that. Okay, so again, as a hint for C and D, multiply 2 at a time. If anyone needs me, I'm here for any questions. I'm going to remain quiet so I don't distract you. And if you need me, though, please feel free. Okay, about a little less than 4 minutes. Okay, I'm going to say about a little less than 3 minutes to go. Okay, so we should be on C, finishing up C and or D by now. Okay, so we're gonna start in about a minute and a half. Okay, last minute. All right, I'm just gonna get this going just so we are okay on time. So for letter B, that is very similar to the one I did. 4a times 3a squared, both squared is gonna be 12a to the 4 minus 8a to the 3 plus 24a to the 2. So that's the first distribution of the 4a squared. Again, coming underneath, minus 15a squared. So I'm going to combine my like terms. Minus 10a. So there's no a term by itself. So I'm going to just leave that alone. And then minus 30. So the final answer you should have got is 12a to the 4. So it was minus 8a to the 3. Now these will combine to a 9a squared minus 10a minus 30. And you may end up with a lot of terms in your answer, but that's okay. Now for letter C, you have something being cubed, which means it's going to be multiplied by itself 3 times. It does not matter which 2 you multiply first, but I'm going to make a strong suggestion. I didn't say this before, but I'm going to suggest that you multiply the last 2 first. Same would go in D, because then you're going to be able to distribute the 6t plus 1 instead of rearranging. But again, please understand, because someone always asks me, does it matter? So guys, right now I'm going to just separate this 4y minus 1. So this is 16y squared minus 4y. I'm so sorry this keeps popping up. Minus 4y plus 1, which is 16y squared minus 8y plus 1. Now that's a trinomial. And then what I'm going to do is bring down the 4y minus 1 that I have not used yet. So all I did was multiply 2 of my 3 binomials together. Now I will get 64y to the 3 minus 32y to the 2 plus 4y coming underneath, and again lining up my like terms. And finally, I will combine. So it's just one more step past what you guys saw with me before. But again, nothing you guys can't handle. So what I'm going to do right here is I'm just going to let you guys sort of digest that. And now if anyone needs a little more time to finish up D, let me just rewrite D down here and then I'll scroll back down. If anyone needs a little more time to finish up D, I'll extend that time for another moment right now. Let me just erase that and then we'll go down. Yeah, Maria, go ahead.
Yeah, I was just wondering on the B example, I got 12a to the 4th minus 8a to the 3rd minus 19a to the 2nd minus 30. So I'm
4a,
trying,
so you have to check all of your terms. 4a squared times 6 is 24a squared.
where's that? 4a times 6. Okay, I missed that.
Okay, Julia?
Hi, the same problem B. So there is minus 5 multiply minus 2a gotta be, I do believe 10a, not minus 10a.
Plus 10a. Thank
Yeah.
you. Thank you. You are right. Not paying attention. And Zelha?
Yeah, it was about the same,
Plus
minus.
10A. Plus 10A.
Yeah.
Yes, thank you. Maria? You still need me?
No, I'm good.
Okay, I'm just gonna lower you guys. Thank you for the correction. Yes, that should have been a plus 10A. My apologies. Be careful with your signs. Don't do what I do. All right, so let's finish up and then we'll, now again, understand, guys, I don't care which order you go in, but again, I think it's a little easier to just do this. So 2 times t, 2t times t is 2t squared. It should go a little slower with my signs here. Plus 6t minus 2t minus 6, 2t squared plus 4t minus 6. And then I will bring into the picture the 6t plus 1. So it will be, here we go, 6 times 2, 12t to the 3, 6t times 4, 24t squared, 6t times negative 6, negative 36t. Okay, so that's the distribution of the 6t. When I distribute the 1 times anything is itself. So again, I will just simply line up my like terms. And I end up with 12t to the 3 plus 26t to the 2 minus 32t minus 6. So now you guys, except for division, which we're going to do in a moment, have completely finished up all of the multiplication. So this would go with lesson 3 homework, which will be due on Wednesday. I'm going to look at them and make sure they're not too lengthy, although I really think more practice is better. I know it's a lot, but you know, it is what it is. So let's start. It's 9 o'clock and we have an hour, but I want to make sure we do this and I can explain about the exam. So let's start with our last questions, which are going to, or last lesson that will be on your exam, which will be lesson 4. Now, to be honest with you guys, you should all be able to do A through E because I did that with you before. So I'm going to actually put about 2 to 3 minutes on the clock. Let's warm up with A through E without me. Then we'll go into the next piece, which will be new. So why don't you guys do that? Okay, so we have about, yeah, some time. Remember, you are also reducing. As you can see, there's not many slides in this lesson. I'm just going to minimize this a second. I apologize. You guys should be able to do that. This one. We'll see how the time goes. Okay. I'm sorry, guys. There you go. If I'm annoying and you want to mute me, that's fine. I just want to say a couple things for people that might have come in late. I am going to talk about the exam at the end of class and how that will work. But please understand that I did send you guys, I believe it's in the announcements too, my YouTube link. That's where these video recordings will be posted, either after class or in the morning, depending on how exhausted I am. There are also some old lessons from my M4 and my R300 from last spring. So you're more than welcome to look at them. I don't know how exciting they are, but they are just another recording that can help. I don't know if the recording came out really that great. I didn't really check it other than I listened to my voice for 2 seconds and freaked. But anyway, I hope it's helping some of you. Okay, I'll do everything in my power to help you guys. And I do thank you all again for last week's understanding. That shouldn't happen again. I'm so sorry. So full steam ahead. I did update the syllabus and post that, the new syllabus with new dates and all of that. And again, I'll talk about the exam after. So I'm going to start these in 30 more seconds. You should pretty much almost be done at this point. Okay, So we are dividing a monomial by a monomial. We are going to subtract the exponents top to bottom, ensuring that we do not have any negative exponents. Please also remember that we are going to make sure that we divide our coefficients. I'm just writing the answers down. I will take any questions after the fact, so just check my work, should be all good. -7, now m and m will just cancel with each other because it's m to the 1 minus 1, which is m to the 0, and that's just 1. And then you would be left with n to the 5. And then 8 and 28 have 4 in common. 8 divided by 4 is 2. 28 divided by 4, so I'm going to write, this is called the GCF. You should all be familiar with that term, which is 4. X to the 5 over x to the 4 is x to the 1. Y to the 9 over y to the 2 is y to the 7. And z to the 3 over z to the 1 is z to the 2. So I'm going to write that you already know this from lesson 2. Okay. Now we're going to go into our second type of division, which is where we have a monomial divisor or denominator, but a polynomial numerator. We're going to divide each term of the polynomial by the monomial denominator separately. So what I'm going to do is I'm going to demonstrate A for you and then let you guys try the other 3 without me. So what we're going to do is, let me just zoom out a little here. We're going to write each term of the numerator over the denominator separately. Whatever the sign is, so it's a positive, we will put in between. So then we just divide each one separately. 18 divided by 3 is 6, x to the 5. 21 divided by 3 is 7, x to the 3. Okay, so this is when we have a monomial denominator. If anyone has any questions on any of the examples, I'm free to answer. If not, about 2 to 2.5 minutes on these for you guys to attempt before we discuss together. You guys are really great. Thank you so much for making this so easy and wonderful.
Professor, I have a question.
Go ahead, Aisha.
How did you get your the exponent?
What do you mean the X? I'm just in A?
Yes. So it
Okay.
says 6 to the 5th, or is that to the 3rd?
That's a 5.
Okay, how did you get the 5?
X to the, oh, I did not mean to do that. Hold on. X to the 6 on top, X to the 1 on the bottom, subtract when you do.
Okay, I get
You're
it.
just doing it twice instead of once.
Okay.
If you don't want to look at the screen, you don't have to. I'm just going to get us set up for the next few. This will save some time. So as soon as I'm done writing these guys, we're going to get started. So just so you know. I actually like this topic, so. Okay. All right, so all I did just to get us ready was I separated the top terms by the bottom term. That's all I did. Now we just divide each one separately. So 30 divided by -5 is -6. And then y to the 2 over y to the 1 is just going to be y to the 1. I wrote it for effect, but you know it's not necessary. Positive 20 divided by 5 is -4. So I'm actually going to subtract that exponent just so we're not confused. So I said 20 divided by -5 is, keep writing the same thing, is going to be -4. And then the y's are actually just going to cancel. So -6y minus 4 would have been your answer in letter B. Letter C, a negative over a negative is a positive, but even more so, the sixes just divide to ones. X to the 4 over X to the 2 is X to the 2. Y to the 6 over Y to the 4 is Y to the 2. Now, a negative 8 and a negative 6 is going to become a positive. 8 and 6 are not evenly divisible, but they do have 2 in common. 8 divided by 2 and 6 divided by 2. So again, reducing fractions should be known from before. That is implied knowledge when you are in this class. X squared and X squared are the same, so they just reduce or cancel. Y to the 6 and Y to the 4 is going to be Y to the 2. You can put it in the top or right next to it, and you are good to go. Finally, the last one, and then we will see how you guys are. So a negative over a positive is a negative. 32 and 12 are not evenly divisible, but they are divisible by 4. 8 divided by 4 is 32 divided by 4 is 8. 12 divided by 4 is 3. 8 to the 6 over 8 to the 4 is 8 to the 2. B to the 5 over B to the 1 is B to the 4. A positive divided by a positive is a positive. The 12s reduce to ones or nothing. 8 to the 4, I'm sorry, 8 to the 9 over 8 to the 4 is 8 to the 5. B to the 14 over B to the 1 is B to the 13. And then a negative divided by a positive is a negative. 10 and 12 are not evenly divisible, but they are divisible by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. 8 to the 8 over 8 to the 4 is 8 to the 4. And the B is just cancel. This one was a little just nasty because of the 2 fractions that don't reduce evenly. But as you can see, it is very easy. Give me 1 second. What did I do? Did I do
For the C, Y to the 6.
Y to the 6th? Thank you. There you go. Thank you. I'm not even reading my own handwriting. Let me fix that nicely. As you guys can see, again, whenever you have that monomial denominator, you just separate and divide. Indira, was that the question or was that the idea?
Yeah, I'm here trying to figure out how you got that number.
It's good now?
Yeah, I was
All right,
confused.
sorry. I'm having a case of Mondays today. Listen, it'll happen, but thank you for calling me out, guys. All right, now comes the fun. When I say fun, I mean, oh my gosh. Now, to be honest with you guys, I'm going to do a long division problem using numbers only to remind you of how this works. But the long division process should already be known. I don't expect you to know how to do this when there's variables, but the steps are the same. So what I'm about to show you right now is old knowledge. So let me explain. This is called our dividend. This is the number that goes inside of the division symbol. This is called our divisor. This is what we are dividing by. The result is called the quotient. So let me give you guys a moment. Our first step in long division is to divide. Now for numbers, it works a little differently, but basically the same process. So 2 divided by 13 doesn't work. 24 divided by 13 is going to be 1. 1 times 13 is 13. So the second step is to multiply. So again, 24 divided by 13 is 1. The next step is 1 times 13, which is 13. The third step is to subtract. Top to bottom, I end up with 11. And the last step is to bring down. Now, when you bring your last digit or your last variable down, that is when you know you're going to be done and there will be a remainder or there won't be a remainder. 117 divided by 13 is going to be, I think it's 8 times evenly, it's 9 times perfectly. So there's that divide step again. Whatever digit I put on top or whatever variable I put on top, I will multiply by. So 9 times 13 is 117. My third step is to subtract. And since there's nothing left to bring down, this would be my remainder. And since there is no remainder, my answer is 19. Okay, so one more time, it is divide, subtract. So divide, multiply, subtract, and bring down. Now, I am going to demonstrate A, then you guys will do B, and then we're going to kind of flip-flop it this way. So I'm going to go extremely slow for A, and I'll show you how this works. And I really need you guys to kind of just watch. It's going to be confusing, so we'll go slow, but please give it some time. When we divide and we have variables, it is very important for every exponent to be present in the divisor and in the dividend. So I'm going to make a note, check for all exponents. Now, normally, this is the part that we're going to check for. So whatever goes underneath here, every exponent must be accounted for. And what I mean by that is I'm going from 2 to 1 to a constant. Now, I know the question that you guys are thinking is, well, what if 1 is missing? We'll get there. Please watch and I will go slow. So when we go and we start to divide, we're only going to use the first term of our divisor to divide. We're going to start with the first term of the dividend. So we're asking ourselves, how many times does x go into x squared? When I teach this, I tell people to do a little bit of math on the side. So x squared divided by x is simply x. That's what goes on top, and we're going to line our like terms up. So one more time, we use the first term of the divisor to divide. X squared divided by x is x. The x goes on top. So there is my divide step. What comes next is multiply. When we multiply, we are multiplying the x times the x that's circled. That's x squared. And we're also multiplying the x times the 3, which is 3x. Distributive property. So x times x is x squared. X times 3 is 3x. Step 3 is to subtract. Now, I always teach my students something very easy. When you subtract, the easiest thing to do is to negate your terms. So what I teach my students, and I've had good feedback about this, is to negate the terms and circle what the sign should be. Why do I tell them to do this? Because what you guys actually have to do is you actually have to distribute the negative into each term. So by changing or negating the signs and circling them, you create a lot less writing for yourself. When I subtract, my x squareds cancel, which is what I want to happen. 4x minus 3x is 1x. And the last step is to bring down. This is my only bring down, so this will be my last round. One more time. I'm now dividing from down here, just like I divided from right there. X divided into x, so we're using the first term of each thing, is just 1. That goes on top. Multiply, 1 times x is x. 1 times 3 is 3. Subtract, but subtract really means to negate. The x's cancel. 2 minus 3 is -1. I am going to do this. Maria, I'm lowering your hand because I'm not open for questions yet. I am going to do this one more time from scratch for everyone to watch. I know this is a little bit annoying for people that understand. So if you don't want to watch, you can start number 2. For those of you that do want to see this one more time now with me, I'm going to do this from scratch once more. So please bear with me as I set this up. So here we go. The original problem said, and I'm just going to rewrite this part. Okay. So X, let me just get the color. X plus 3 is the divisor, excuse me. X squared plus 4x plus 2 is in the inside. So here we go one more time. X squared divided by X, so we use the first term of each, is X. That goes on top. Multiply. X times X is X squared. X times 3 is 3X. Subtract. Subtract means to negate. So minus, minus. These cancel. I'm left with X. And there's my bring down. I'm dividing again. So the first term down here and the X on the original part. X divided by X is 1. 1 times X is X. 1 times 3 is 3. Subtract, so I negate, the X's cancel, -1. Now, the way that we write our answer, there are 2 ways. X plus 1, remainder -1, since the -1 is left over. Or X plus 1, and then the remainder goes over the original divisor. These mean the same thing. I am not going to tell you which one they may or may not put on a final. I'll say prepare for both, but that's the idea. So here's what we're going to do. I know some of you have questions, but I want to keep the flow because it is already 9:20. I'm putting about 2 minutes on the clock for B. I'll take questions. Maria, you're up.
Professor, is there any other way that we can do this? Because
Yeah.
this is very confusing for me.
Okay, well, it's the first time you're seeing it, and I'm sure you're not the only one in that boat. So unfortunately, there is not. Not in this class. There is something called synthetic division, which you would be taught in a pre-calculus class. I apologize that there is no other way. Yes.
Thank you.
You're welcome. You will get used to it. There's going to be a lot of nights in this class that you guys are going to be confused, unfortunately. Okay, I'm going to give you about another minute and a half to try number 2 without me. Remember that, by the way, both homeworks. So I don't know how much of the homework I'll be able to do with you guys tonight. Homework 3 and 4 are due on Wednesday. I'm going to also review Wednesday. The review sheet is available. Guys, I'm going to remind you, I am not accepting emailed homework. And also, in order to get credit for homework, you cannot just give me your answers. So if any of you, there's a couple of you who have emailed me, if you're still having issues uploading to Blackboard, at the end of class, I will show you how to do that again. One of the things for your exam will be that you will have to upload your work. So I'm letting you know that just giving me answers will not give you full credit on any homeworks going forward and or any exams. Let's give you guys another 45 seconds to a minute. We'll get started. If anyone feels adventurous, you're more than welcome to go to letter C. After we go through D, I'm going to stop because I want to talk about your tests. Then I'm going to finish with the rest of these where we're missing a term somewhere. I'm actually probably going to skip down to the bottom to show you. We'll get there. Okay. So I'm going to get going on B. By now, you guys should have started this. So y squared divided by y is going to be y. Y times y, so you're just doing this, is y squared. Y times 2 is 2y. Negate the y squareds cancel. Negative 3y minus 2y is negative 5y. And I'm going to bring down the 1. I'm going to divide again. So negative 5y divided by y here is negative 5. Negative 5 times y is negative 5y. Negative 5 times 2 is negative 10. Negate, these cancel. 1 plus 10 is 11. And my final answer, because that is my remainder, is y minus 5 remainder 11, or y minus 5 and the remainder over the original divisor. For anyone that is ready to try C, I'll ask you guys to get C going. I'm open for any questions on A or B at this time. It's going to click eventually. Remember, these can also be an answer key for you guys. I'm just going to minimize my screen. I want to check on one quick thing. So if anyone needs me, just feel free to unmute because I can't see your hands at this point.
Professor,
Yeah.
when in B, when you are doing minus 5y plus 1, and then we have minus, then we're multiplying it. You put plus in both of
So
them?
you're negating. The word negate means to go opposite the sign. So the fact that it was negative 5y minus 10, when you negate, they become plus. And the reason why I circled the sign is because I feel that it's easier to follow the plus signs that are circled. You have to negate when you subtract. So every time you subtract, what if it's negative, it becomes positive, and if it's positive, it becomes negative.
Okay,
Okay?
yeah, I guess.
It's gonna take time. It's a lot of practice. It's a new topic. This is gonna happen pretty much every night for the rest of this semester, to be honest. Marianne?
Professor? Yes, I'm just trying to understand the third step on question B.
Mhm.
Y minus 5, is that remainder 11?
Yeah, that's remainder 11.
Okay.
And then another way that you might see, most likely on a test, you would see it written like this, but it can be written as 11 over the divisor, which is y plus 2. So I just want to prepare you in case they show one versus the other. Does that make sense?
Yes.
Okay. So same with the last problem. It was x plus 1 remainder negative 1, or x plus 1 and then negative 1 over x plus 3.
I have a
They're just two ways of writing your answer. Basically, that's what it means.
And that's y minus 5 plus 11 over y plus.
Yeah. Yep. You're just adding the remainder to whatever the quotient is.
Oh, I see. Okay.
Yeah.
Okay.
All right. Number 3 is coming up, guys. I just want to keep the schedule on deck here. So let's try number 3. Hopefully we'll start to feel a little bit better now. So again, I'm going to go nice and slow. So if those of you struggling with any step, stay with me now. Don't go ahead. Don't go back. X cubed and x is x squared. I think this step is really helpful. X squared times x is x cubed. X squared times 3 is 3x squared. For those of you that are still stuck with this step, so I'm negating. So because this is plus, it becomes minus. Because this is plus, it becomes minus. Those cancel, x cubed minus x cubed. So I have 6x squared minus 3x squared, which is 3x squared, and I'm going to bring down. Now, please understand we're only going to bring down one term at a time. So in this case, the negative 4x comes down. Now I'm just one term at a time. The 3 is going to be a bring down later. 3x squared divided by x is 3x. And because it's positive, which is why we put plus, if it was negative, we would put minus. By the way, you see how I use different colors? It helps me keep track. So 3x times x is 3x squared. 3x times 3 is 9x. Negate, negate. I'm making them both minus because they were both plus. These cancel. I'm left with minus 13x. And since I have one more bring down, the 3 comes down. New color time. Negative 13x divided by x is negative 13. Negative 13 times x is negative 13x. Negative 13x, excuse me, negative 13 times x is negative 13x. Negative 13 times 3 is negative 39. Now, here's where a lot of you guys are getting confused. So, negative becomes plus when I negate. Negative becomes plus where I negate. Negative 13 plus the 13 cancels. 3 plus 39 is 42, which is my remainder. So my answer is either x squared plus 3x minus 13, remainder 42, which is most likely what you would see on a test, or x squared plus 3x minus 13, and then the remainder over the divisor. Okay? D is all yours, guys, unless you need me. Then I might skip down and do G and H, and then we can end with E and F. But right now, I'm open for questions at this point. I actually want to try to see. I'm just trying to find something. You guys should be okay at this point. There we go. I'm going to start the next one in a few moments. What's going on here? Okay, so about 30 seconds, we'll start D. Then I'm going to demonstrate a different one for you guys. Sorry, I'm just trying to find something for you guys that I can't seem to find on here. All right, whatever, it doesn't matter. All right, let me get you guys going. So with question D, so y plus 5 on the outside, and then 2y squared minus y minus 8 on the inside. By the way, I failed to mention for B, C, and D, every term is accounted for underneath the division. So here we go. 2y squared divided by y is going to be 2y. 2y times y is 2y squared. 2y times 5 is 10y. Negate, this becomes negative. Negate, this becomes negative. These cancel. So I have a negative 1y minus a 10y, which is a negative 11y, and I'm going to bring down my minus 8. Here we go again, round number 2. I'm going to just get rid of these arrows, and here we go. Now, that was my last or my only bring down, so this will be the last round. So negative 11y divided by y is negative 11. Negative 11 times y is negative 11y. Negative 11 times 5 is negative 55. So this negative becomes positive. This negative becomes positive. Negative 8 plus 55 is going to be 47. And since there's nothing left to bring down, that 47 is my remainder, or 2y minus 11 plus 47 over y plus 5. But again, that would be what you'd probably see. All right, so here's what I want to do, just because it's already 9:35 and I don't want to not show you these. I want to show you what happens when we are missing a term. So I'm going to ask you guys to scroll down to G, and I'm going to demonstrate G, and then you guys will try H without me. There is a missing term here. We are missing our X term, X to the first. So when we set this up, the X minus 8 goes on the outside, but we need a placeholder for the missing term. And so we normally use a 0 as a placeholder. I'm going to give you guys one more example. I might skip E and F and just do a different one after, but this is what we are going to do. 5x squared divided by x is 5x squared. I'm sorry, is 5x. 5x times x is 5x squared. 5x times negative 8 is negative 40x. Negate. Negate. These cancel. Now, the fact that that 0x is there, sorry about that email, means that I can now just subtract or add straight down. 0x plus 40x is 40x, and there's my only bring down. 40x divided by x is 40. I should have used the different colors. I apologize. Doesn't really matter, but it does. 40 times x is 40x. 40 times negative 8 is negative 8. Negate. Negate. My remainder is 9. So my answer is 5x plus 40 with a remainder of 9. Okay, your guys' turn without me. I'll give you guys a few minutes, but you're going to do the next one.
Isn't 40 times 8 negative 320?
What is wrong with me tonight? I don't know what is wrong with me. Why did I not write 320? Thank you. I don't know what the heck's going on with me tonight. It is 320. 40 times 8 is negative 320. Thank you. So this should be 321. My apologies. No, it's not okay. 321. So it's 5x plus 40. 5x plus, let me just fix this because I screwed this all up. All right, you guys get a freebie another round because I messed this whole thing up. I'll do it a little quicker. Sorry to those of you that got it right. It's my fault. All right, so x minus 8, let me just do that again. 5x squared plus, you guys can start the next if you were okay. So 5x squared divided by x is 5x. 5x squared minus 40x. I know that part is right. This will negate. We end up with 40x. We're going to bring down our plus 1. Okay. Now we're doing 40x divided by x, which is just going to be 40. Let me just make sure everything looks good here. That's a 5x on top, 5x squared minus 40x, negate, yep, 40x. Okay, 40 times x is 40x. 40 times 8 is negative 320, which I clearly did not write. Thank you again for the correction. 321 is our remainder. So 5x plus 40, remainder 321, or 321 over x minus 8. Thank you again, Deanna, for that correction. I really appreciate it. All right, so H is for you guys. I just want to see if I can nab another question that I had with long division with a missing term. So I'm just going to ask you guys to bear with me as I look for that. So just give me a few moments, but you guys can work on that one. Hopefully it's clicking a little more for you guys now. You can add I. What I'm going to do is we're going to skip E and F, and I will work them out and post them for you guys. I'd rather you try one or two more with missing terms. Okay, so let's add this as I. We're going to do these 3 last problems for tonight. Okay, I'll start up H with you guys soon. Just looking for one more I should have really given you guys. Okay. Okay, a few more seconds. Okay, let me start up H for you guys. That's a nice one. And then we're going to do this one after. I really like this one. This is a tough one. IJ. X to the 4 minus 402 divided by X plus 3. So these will be our last 2 problems after H. And then I'm just going to ask you guys to hang on with me. And what I'll do is I will work out E and F on the bottom of this page for you guys for so you can practice and check your work. So let's start with letter H over here. So I'm just going to separate the work from the last one a little bit. Okay, so we have, so we have the division, which will be occurring first, and we have to make sure that we account for all terms. So of course, we are missing again the X term. So we're going to write it as 3x squared plus 0x plus 2. 3x squared divided by x will happen first. That is 3x. 3x times x is 3x squared. 3x times -7 is -21x. Negate, negate. You're left with a positive 21x because 0 plus 21x is just going to be 21x, and then a plus 2. So if you're good here, you're in good shape. Now we are going to do 21x divided by x, which is 21 positive. 21 times x is 21x. 21 times -7 is going to be -147. Negate, negate. These cancel. 149 is our remainder. We know it's our remainder because nothing is left to bring down. So 3x plus 21, remainder 149. I'm going to take questions in a moment, but I would like you guys to be adventurous. Let me just leave it there and try I. So if you can't see, it's 4x cubed minus 11x minus 5. So remember, you're going to put a 0 as the missing term. I'm going to actually start this one sooner than later because I want to show you guys J as well. Maria?
Yeah, I have a question actually on the H. So when you bring down 21x, when you are negating it, wasn't it supposed to be positive in the first place?
It was positive, so when you negate, it becomes negative.
Okay.
Negate means go opposite the sign.
Yeah, I know. So if you negate it, how come it's again positive? How come it doesn't
It's
stay
not
negative?
positive. This says negative right there. That says minus.
Oh, okay, I didn't see that.
That's minus. Yeah, that's a minus. I'll make it.
And then how did you get 21 on the top?
21x divided by x. When we got to here, 21x divided by x is 21. It's written right here.
Okay, thank you.
You're welcome. Okay, I just want to make sure you guys are set up correctly with the next one. So the missing term was the x squared term. If you found that, then that's great. So we're going to have 4x cubed. The reason why we put 0 as a plus is it's always nicer to look at a plus rather than a minus. Minus 11x minus 5. So now we've accounted for every single term. So what I wanted you guys to hopefully figure out without me was that you're going to always put the missing term as a 0, but then x to the 2, x to the 3, whatever term is missing. So I'm just going to keep on going with this one. 4x cubed divided by 2x is going to be 2x squared. That will go right here. 2x squared times 2x is 4x cubed. 2x squared times 1 is 2x squared. Negate, negate. When you negate, these cancel if you did it correctly. So 0 minus 2x squared is minus 2x squared. And I bring only one term down at a time. Okay, so I'm going to pause just to give you guys a few moments to catch up here. Okay. So now comes round 2. We only use the first term to divide. So negative 2x squared divided by 2x is just going to be a negative 1x, which we'll just write as negative x. Negative x times 2x is negative 2x squared. Negative x times 1 is negative x. Negate, negate. Negative 11 plus 1x is negative 10x. And there is our last bring down. So I'm going to pause to let you guys catch up there. Okay, last round, so a different color. Negative 10x divided by 2x. I love doing this on the side. I think it's so helpful. Is negative 5. Negative 5 times 2 is negative 10x. Negative 5 times 1 is negative 5. Negate, negate. Now these cancel and these cancel. My remainder is 0. Because my remainder is 0, I don't have to write my remainder, and that would be my answer. Okay, so I'm going to give you guys a head start on J. We're going to finish with J. Then I'll just mention a couple of things about Wednesday and your test, and I'll get more into that on Wednesday. But I'm just going to say you may have multiple terms missing in J. So your homeworks 3 and 4 need to be uploaded by Wednesday. I know that's a lot, but it is important for you guys to understand. So I'm just going to get this set up and you could check when you're ready. This is a tough one, but it is a doable one. So it could be a test question, guys. You're missing the 0x, you're missing the x cubed. You're missing the x squared and the x term. So all of those need to be accounted for. So I'm going to get us started just because I want to make sure we finish by the time. X to the 4 divided by x, I'll do that up here, is going to be x cubed. X cubed times x is x to the 4. X cubed times 3 is 3x squared. 3x cubed, excuse me. I will negate, so these cancel. I will negate. I'm left with a negative 3x cubed, And I'm going to bring down a 0x squared. Even though it's 0, it comes down. Okay, round 2. So the division always occurs after the bring down. Negative 3x cubed divided by x is negative 3x squared. Sorry, my thing just minimized on me. Negative 3x squared times x is negative 3x cubed. Negative 3x squared times 3 is negative 9x squared. When I negate these cancel. When I negate, I'm left with 9x squared. And I will bring down my next term, which is 0x. Next round coming up. So 9x squared. It's the same thing. Oh, sorry. 9x squared divided by x. I'm doing that too close, but it's fine. Actually, it isn't fine. But 9x squared, I'll do this over here. Divided by x is going to be 9x. 9x times x is 9x squared. Oh, God. 9x times 3 is going to be 27x. I'm going to negate. I'm going to negate negative 27x. And here is my last bring down. So it's just extra steps each time, but it's the same steps each time. Negative 27x divided by x is going to be negative 27. Sorry. Negative 27 times x is negative 27x. Negative 27 times 3, I'm going to cheat with a calculator because of time, is 81. Oh, it's negative 81, excuse me. So this will negate, and I'm left with negative 321 as my remainder. So my answer is x cubed minus 3x squared plus 9x minus 27, remainder negative 321. It is a challenging problem, but it is nothing that you guys haven't seen. So I would like to end before I take any questions from anyone by saying the following, just so that people who want to go can go. I will finish E and F here, and I will then post this. So we have now completed all of the material for your exam. When you come in on Wednesday, excuse me, I'm going to start promptly at 8:10. I am going to start with homework 3 and homework 4. And then I'm going to go over the review, which is on Blackboard. I am going to probably start lesson number 5, but anything that's on 5 will not be on your exam, but I still would like to introduce it. Your exam will occur Monday, the 5th. I will give more information about the exam. The exam is going to be 25. I'll give more, Wednesday. The exam will be 25 multiple choice questions. You will have 1 hour and 15 minutes to complete it. I'll talk about the time window in which you guys can take the exam, as well as uploading work on Wednesday. I really would prefer to get questions in so you guys can practice. So what I'll say this time or at this point is I will post the work either tonight or tomorrow morning, as well as the recording. If any of you still need me,